Welcome. This is a time series analysis course. My name is Nicoleta Serban. I'm Associate Professor in the Stewart School of Industrial and System Engineering. In this lecture is on multivariate time series analysis, and for this lesson, I will introduce a concept that is very important in multivariate time series analysis, particularly Granger causality, and I'll also introduce prediction for the VAR model. The structure of the VAR model provides information about the a series of time series and along with forecasting ability for other time series. The following intuitive notion of a variable's forecasting or a time series forecasting ability is due to Granger, who introduced the concept in 1969. If a time series Y1 is found to be helpful for predicting another time series Y2, then Y1 is said to Granger cause Y2. Otherwise, it is said to fail to Granger cause Y2. Formally, we say that Y1 is said to fail to Granger cause Y2 if the mean square error of the model without lagged observations of the time series Y1 is the same as the mean square error of the model with lagged observations of the time series Y1. Clearly, the notion of Granger causality does not imply true causality. It only implies forecasting ability. In a bivariate VAR model with order P for two time series Y1 and Y2, we have that Y2 fails to Granger cause Y1 if all of the P VAR coefficient matrices pi 1 to pi p are lower triangular. As shown on the slide, the coefficient matrices corresponding to pi 1, the coefficients corresponding to pi 1 to location in the matrices are 0. If Y2 fails to Granger cause Y1 and Y1 fails to Granger cause Y2, then the VAR coefficient matrices pi 1 to pi p are diagonal. This means that there is no temporal lag relationship between the two time series. More generally, for an n-variate multivariate time series, we identify Granger causality in the same way. For example, if we have a trivariate multivariate time series, we need to evaluate Granger causality among all pairs among the three time series. If we consider Granger causality on Y1, we need to consider it with respect to both Y2 and Y3. We say that Y2 fails to Granger cause Y1 if all the coefficients on lagged values of Y2 are 0 in the equation for Y1 for the first time series, and that Y3 does not Granger cause Y1 if all of the coefficients on lagged values of the third time series Y3 are also 0 in the equation for the first time series Y1. It is possible that only one of the two time series Y1 or Y2 to Granger cause Y3, both, or none. How to evaluate Granger causality? We can use hypothesis testing procedure where the null hypothesis is that the coefficients corresponding to the Granger causality are 0. For example, if we are interested to identify whether Y2 Granger cause Y1, the null hypothesis is that the coefficients on lagged values of Y2 are 0 in the equation for the time series Y1. More generally, for a pair of time series YK and YL among the n time series, we test the null hypothesis that all the coefficients on lagged values of YK are 0 in the equation for YL. Rejecting the null hypothesis means that YK does Granger cause YL. Last, I will only briefly discuss forecasting of time series in a VAR model. Since the VAR models m time series simultaneously, we will need to forecast all n time series or only those of interest. Since VAR is a multivariate AR model, we can use the chain rule of forecasting. The best linear predictor in terms of minimum mean square error MSE of YT plus 1 or one step ahead forecast based on past data at time t is obtained from the linear equation of the model by plugging in the lagged values of the time series as provided on the slide. Forecasts for longer horizons H step forecasts may be obtained using the chain rule of forecasting by plugging in predicted lag values of the time series. In summary, in this lesson, I introduced the concept of Granger causality, which is of great relevance in multivariate time series. I also briefly introduced the method used to forecast VAR model. Thank you. Welcome. This is a time series analysis course. My name is Nicoleta Serban. I'm Associate Professor in the Stewart School of Industrial and System Engineering. This lecture is a multivariate time series, and in this lesson, I'll illustrate the concept of Granger causality and prediction for the VAR model. We'll return to the example in which we are interested in modeling the bivariate time series consisting of the unemployment rate and the interest rate in the U.S., motivated by the monetary policies in 2017 towards an increase of the interest rate. Again, this is the output for the coefficients corresponding to the difference in the interest rate time series. As noted before, the coefficients corresponding to the difference in unemployment are statistically significant for orders 1 and 2. Thus, we do identify some lagged relationship of the change in unemployment onto the change in the interest rate as expected from how interest rates are established by the Fed. Let's look at the Granger causality more formally. That is, we perform a statistical inference to address the following question. Is the change in interest rate led by the change in unemployment rate, statistically speaking? To do so, we can apply the Wald test. For this test, we test whether the coefficients corresponding to the lag values of the difference in unemployment rate are zero, with the alternative hypothesis that at least one coefficient is non-zero, hence Granger causality. Just as for testing for order selection, we use the Wald test function in R. The vector for the coefficients for the difference interest rate consists of all estimated coefficients for the interest rate time series except for the constant or intercept, thus removing the last coefficient. The matrix of the covariance matrix of the coefficient is defined here as var period d int rate. We apply here the Wald test, but not on all the coefficients, only on those corresponding to the lagged values of the unemployment time series. Hence, this specification of the terms of the option terms equal to the indices for the coefficients corresponding to the unemployment time series. Based on this test, the p-value is approximately 0, which means that at least one coefficient is not 0, thus indicating that there is a significant temporal lagged relationship of the change in unemployment rate onto the change in the interest rate. Thus, change in unemployment rate Granger causes the change in interest rate. Let's also see whether the VAR model improves the forecasting of interest rate when accounting for both autocorrelation with lagged values of the interest rate and cross-correlation with lagged values of the unemployment rate. We'll forecast the months of January, February, and March in 2017 to see whether our model would forecast the change in an interest rate better using the VAR model versus a univariate AR model. We'll use the first 67 years of data. The training data consists of the 67 years before 2017, and this training data is used to train the model, where the last 3 observations the months of January, February, and March in 2017 correspond to the testing data. I first applied the EAR model to the change in interest rate using the ARR command and predict the last 3 observations using the predictR command, specifying the model with the specification of the model fit and the number of lags ahead to be predicted. Next, I predicted based on the VAR model. Similarly, I used the training data to fit the model and the testing data to predict. The predict function again is predict just like in the AR model. This plot shows the change in interest rate since September 2016 until March 2017. We can see 2 small changes in November 2016 and February 2017 corresponding to the first 2 increases in interest rate after many years without any change. The red and green circles correspond to the forecast based on the 2 models. They both predict that there will be no change in the interest rate. This is expected since the interest rate did not change for many years and any model will predict no change regardless whether using information from other economic indicators such as unemployment. Thus, while unemployment does Granger cause interest rate, this is not reflected an improvement in the forecasting accuracy. This may be only for the 3 months because they're in this example. The forecasting may improve, however, if we would consider a different time period. In summary, in this lesson, I illustrated the Granger causality with a data example. Thank you.